Imagine a universe where the laws governing time and space are far more complex and fascinating than we've always believed. For decades, we've accepted that time flows in a single direction and that space is composed of three dimensions that together form the stage on which all reality occurs. But what if all of that were just part of a much deeper reality? What if time, instead of being a straight line, had several independent directions, with space emerging as a secondary manifestation? These questions are at the heart of a revolutionary theory that could forever change our understanding of the cosmos. And join us as we explore these bold ideas which challenge our certainties and open the door to a universe full of unsuspected possibilities.
According to a recent study, time could have three dimensions, while space would be a consequence of them. Researchers suggest that this mathematical model allows for more effective verification of the mass of known particles and other physical properties. More often than we imagine, science challenges our certainties, forcing us to reconsider what we took for granted. For decades, we have maintained that there are four clear dimensions: three spatial dimensions, width, height, and length, plus one temporal dimension. However, a recent paper, published in the journal Reports in Advances of Physical Science, suggests the opposite: time could have three dimensions, with space resulting from them. Led by Gunther Klatechka, the authors propose that time, and not the combination of time and space, could be the fundamental property where all physical phenomena unfold. Klatechka and his team argue that time has three dimensions, rather than a single continuous progression, and space emerges as an associated manifestation. The three dimensions of time are like the canvas on which everything is painted, Klatechka explains in a statement. Space exists, but it is more similar to the paint on the canvas, not the canvas itself.
These ideas contrast with conventional physics, which asserts that one dimension of time along with three dimensions of space make up reality, what we know as space-time, a concept developed over a century ago that used time and space as a single unit. Klatechka's mathematical formula, which unites six dimensions of time and space, may bring scientists closer to a unified explanation of the universe. Temporal dimensions that exceed our everyday progression are difficult to conceptualize, and theoretical physicists have proposed numerous variants. In this context, Klatechka's work adds to a long tradition of theoretical research in a field that's a conventional physics. The mathematical structure of three-dimensional time improves on previous proposals by producing verifiable reproductions of particle masses and other physical properties, adds Klatechka. Past proposals for three-dimensional time were largely mathematical constructs without concrete experimental connections. Our study turns this mathematical possibility into a tangible, verifiable theory with multiple independent channels of verification. This theory could help predict the characteristics of still unknown particles and contribute to the search for the origin of mass, helping to solve one of the great questions in physics. The concept of three-dimensional time suggests that time, like space, has multiple independent directions, generally imagined as three axes, analogous to the x, y, and z axes in space. The study explains that to understand this, imagine walking along a straight path, experiencing time as we know it. When a side path emerges, if we could walk along it while at the same instant in regular time, we might encounter variations of the same day. Moving along this perpendicular path could explore different outcomes of that day without moving forward or backward in time as we know it.
The existence of these different outcomes is the second dimension of time. The method for moving from one result to another is the third dimension. Klatechka claims that this theory overcomes problems with previous theories of three-dimensional time based on traditional physics. It also asserts that causes precede effects even with multiple time dimensions, but within a more complex mathematical structure. Theorists such as Itzhak Bars believe that the second and third dimensions of time emerge at extremely high energy levels, such as at the beginning of the universe or in high-energy particle interactions. It is believed that the search for three-dimensional time could answer major questions in physics. Klatechka's approach could even contribute to solving the greatest challenge, unifying quantum mechanics, behavior at the microscopic scale, with gravity in a single quantum theory of gravity. A quantum theory of gravity could guide or become a grand theory of the universe, the so-called theory of everything, unifying the fundamental forces, electromagnetism, the strong and weak nuclear forces, and gravity. The Standard Model of particle physics already unifies the first three. Gravity is explained through Einstein's general theory of relativity. However, they coexist incompatibly, so physicists are searching for an integrative theory of everything. Finding the origin of particle masses is key to that quest.
Klotetschka believes his theory of three-dimensional time can contribute in this regard. Its structure accurately reproduces the masses of particles such as electrons and quarks, explaining why these particles have their specific masses. According to Klotetschka, the path to unification may require a fundamental reconsideration of the nature of physical reality itself. His theory shows that by considering time as three-dimensional, multiple physical puzzles can naturally be resolved through a coherent mathematical framework. This bold approach, which reimagines time with extra dimensions, not only challenges conventional theories but could offer a new way of looking at the universe, helping to bridge the gaps between small and large-scale theories of physics. By providing a possible connection between microscopic quantum behavior and macrocosmic gravitational structure, Klotetschka's three-dimensional theory of time represents a new horizon in science, opening the door to exciting discoveries that could revolutionize our understanding of the universe.
The proposal of three-dimensional time represents a conceptual revolution in physics, as it invites us to rethink traditional notions about the structure of the universe. If this theory is confirmed through future research and experiments, it could facilitate a crucial breakthrough in the search for a unified theory that combines quantum mechanics and gravity. This, in turn, would open up new avenues for understanding phenomena that remain mysterious, such as the nature of dark matter, dark energy, and events in the first fractions of a second in the cosmos. Furthermore, the ability to predict the properties of as yet undiscovered particles can guide future experimentation at particle colliders, accelerators, and astronomical observatories. The idea that time is not a single continuous line, but a more complex and multifaceted structure, could also impact technological and applied areas, such as quantum communications, materials physics, and cosmology. Ultimately, if this model is validated, it will not only transform our understanding of time and space, but could also trigger a scientific revolution in how we understand the universe as a whole. The ambition now will be to test whether these ideas can be integrated into an experimental framework and how they might influence the next generation of physical theories, providing answers to questions that have fascinated scientists and philosophers alike for centuries.
If you enjoyed this video, give it a like, share it with your friends, and subscribe so you don't miss out on future ideas that challenge us to think outside the box. We'd love to hear your thoughts in the comments below. Until next time, and don't forget to always maintain that curiosity that drives progress. Also, explore even more fascinating content on our channel. From life-changing tips and cutting-edge technology, to the mysteries of spirituality, travel to various countries, delicious recipes, health hacks, and language learning, there's something here to spark your curiosity and elevate your life. Dive in and discover a world of knowledge awaits us.